Okay, this is the properties of Exponents I homework video solutions, and we're going to use properties of exponents here to evaluate the following exponentials. Now, if you remember from lecture, we have a base to a power multiplied to another base to a different power. What we're going to do here is we're going to keep the base and we add our powers. So the focus here is going to be on simply adding my powers when I have two exponentials with the same base. So the first exponential is 2 to the second power. The second is 2 to the third. So what that would be is 2 to the 2 plus 3, because we're going to add the powers. And that gives us 2 to the fifth power. Now, if you remember what an exponential is, it's repeat multiplication of the base. In this case, it's 2. And since my power here is 5, I should have 5 of these 2's multiplied together. So repeat multiplication, and notice that we do have 5 2's. So when we multiply, 2 times 2 gives us 4, times another 2, times another 2, times another 2. 8 times 2 times 2, 16 times 2, for a final answer of 32. So this is what we discussed in class, and we're going to use this here, this property for exponentials. Same base, add the powers. And that's it. So that's number 1. Let's look at number 3. 4 to the first power times 4 to the second power. Notice we have the same base again. We're just going to add the 2 powers. We're going to keep that base of 4. So this will be 4 to the 1 plus 2, which is 4 to the 3 power, or the third power. Okay. Now again, that just simply means to take my 4 I have 3 of these 4's, and I'm going to repeat multiply. So 4 times 4 is 16, times another 4 gives me 64. This is number 3. Number 5 is 3 squared times 3 squared. Notice again, same base, and we're going to add the powers. So we keep the base, and we add 2 with 2. We get 3 to the 4th power. Remember what this means. I got 1, 2, 3. I got 4 3's, and we're multiplying these numbers together, this base 3. So 3 times 3 is 9, times 3 times 3. 9 times 3 is 27, times 3, and 27 times 3 is 81. This is number 5. Number 7, we have x to the second power times x to the third power. The same properties apply, because notice again, same base, the base is x. Keep the base. I have a power 2 and a power 3. I'm going to add 2 with 3. And 2 plus 3 is actually 5. Now, we can't evaluate this because the base is unknown. It's just represented by the letter x, or the variable x. So this is x to the 5th power. And go back and notice that I simply add my powers, 2 plus 3. And I keep the base here of x. Number 9, x to the 4th power times x to the 3rd power. Again, same base. I'm going to keep that base. And I'm going to point another detail out I haven't been pointing out, that we are multiplying these exponentials together. So in every one of these problems, we've multiplied the exponentials. This property has to do with us multiplying two exponentials together. And in that case, we simply take the powers and add them, and we keep the base. So that's what we've been doing, and that's what we're going to continue to do. We got 4 and 3. So this is 4 plus 3. I get x to the 7th power. Number 11, we got here 3 exponentials, each with a base of 3. Of x. Notice my base in each case is x for these 3 exponentials. Notice again we are multiplying these exponentials. So we're going to keep our base, and we're going to add the powers. So this is 2 plus 4 plus 3. This will give us our new power. So we'll end up with x to the 9th power, because 2 plus 4 is 6, plus 3 is 9. And we are done. Notice we just simply added those powers, and we kept the base. And that's what we're doing here. Number 13, x to the 1st power times x to the 2nd power times x to the 3rd power. Okay. Our base in each case here is x, so we're going to keep it as x here. And notice again, we are multiplying these exponentials together. So we take each power and we add them. 1 plus 2 plus 3. We get x to the 6th power, because all we have to do here is add the powers and keep the base. We're done. Number 15, x squared times y cubed. I want to point out to you something interesting about this problem. We cannot use our property because of the fact that we have 2 exponentials. They are being multiplied together. However, you have 2 different bases for your exponentials. In one case it's x, and in the other case it's y. So we can't use the property. The property only applies when we have the same base for our exponentials. Therefore, we're actually done. This is simplified or evaluated, whatever you want to call it. You need the same base in order to use that property. Number 17, x cubed times x squared times y to the 4th. Actually, 17 is not this. We made a mistake. Let's see what it is. 17 is x squared, x cubed, times y squared, times x to the 4th power. Now notice again, we have multiplication, okay? In fact, we have 2 multiplication problems with 3 exponentials. Base x, base x. Over here, we have a base y. So we already seen in the last example that we can only multiply exponentials that have the same base. Now, I want to point out another detail here that we talked in class. That this is multiplication, and the order in which we multiply does not matter. That's an important thing to remember. That means we can switch the order. So I can put my exponentials both with the base x next to each other. I can switch the order, in other words. So we can write this as x to the third times x to the fourth times y squared. Again, we are multiplying here, and we can only multiply the two exponentials that have the same base, in this case x. So what that'll give us is x to the 3 plus 4 now, and we have to keep this as y squared. So the only exponentials we can multiply are the ones with the same base. Excuse me. And we are going to add the powers. 3 plus 4, because power 3, power 4. That's going to give us x to the 7th times y squared, or simply x to the 7th y squared. This is simplified. Number 19, x squared, y to the 4th, x cubed. Like the last problem, we're going to have to switch our order because the order in which you multiply doesn't matter. I can switch the order of my exponentials. It's multiplication. Notice that. We can switch the order. And here, the only two exponentials we can multiply are the ones with the same base. So we're going to keep that base x. We're going to add their powers. And this will be times y to the 4th power. So notice, power 2, power 3. Add the powers, you get x to the 5th times y 4th. And you're done. Number 21, x cubed, y to the 4th, x to the 5th, and y. Again, multiplication here, so I want to point this out. This time I have 4 exponentials, and you might say, well, where's the power for y? Well, like we talked about in class, if you don't see a power there, it's understood by default to be 1. So we're going to here switch the order in which we multiply, because that's how multiplication is. It allows us to switch our order. 5 times 3 is the same as 3 times 5. 8 times 4 is the same as 4 times 8. So we can switch the order any way we like when we have a string of multiplication. So I'm going to keep my x bases together and my y bases together. And the reason being is, notice again, this is still multiplication. But I put my x bases next to each other so I can combine these two exponentials by multiplication. Meaning, this is now x to the 3 plus 5 power. This is still times, notice here, y and y, same base. I can add those powers now and keep my base y. So go back, power 3, power 5, 3 plus 5. Power 4, power 1, 4 plus 1. This gives me x to the 8th power times y to the 5th power. And we're done. You may see in the back of the book that there is no multiplication sign. You already know by default. By default, always, if there's no sign there, that means to multiply. And we're done. (23) is 2x squared y squared x to the 5th and then a y by itself again. Notice here we have y by itself, that's y to the 1st power by default. We're now going to switch our order because you have multiplication, blank spaces really. And those blank spaces by default really represent multiplication. So we have a string of multiplication here. We can, what's the phrase again? We can switch the order. switch the order in which you multiply. And you're going to do it in a way that simplifies your expression. So we got the 2. We're going to keep the constant 2 out there. X squared times x to the 5th, y squared times y to the 1st. We're going to keep our x bases together and our y bases together separately. And notice this is going to be now 2 plus 5 for the x base and 2 plus 1 for the y base. So that gives us 2x to the 7th power, y to the 3rd power. Okay, let's go back. Base x, base x. Keep the base x. Base y. Keep the base y. You're now going to simply add the powers. 2 and 5 is 2 plus 5, which gives you 7. 2 and 1 is 2 plus 1, which gives you 3. And you're done. 25. 3x cubed times 2x squared. Again, we have blank spaces. That means multiply. Now, switch the order, because the order in which you multiply does not matter. So if I switch this order, I'm going to switch it in a way that helps us simplify this expression. So I'm going to put my numbers together, 3 times 2. And this is number 25. Okay. So now I have x to the 3rd power times x to the 2nd power. I know 3 times 2 is 6, and I'm going to be able to add my powers here because we have the same base. And 3 and 2 is 3 plus 2. We get 6x to the 5th power. And we're done. (27) 4x cubed times 3x squared times 2x. Again, blank spaces. Here, here, and here. We have a string of multiplication. Switch the order, because the order in which you multiply doesn't matter. Switch it in a way that helps you simplify. So I'm going to put all my constants together, all the coefficients, all those numbers, and now I'm going to put my exponentials next to each other. Don't forget, there's a power 1 here. If they don't have a power, it's always understood by default to be 1. So now again, notice you still have that string of multiplication, just to point that out to you. And now we're going to multiply. 4 times 3 times 2 is actually 24. Now I have the same base, so that allows me to keep my base and add my powers. The base here is x. Same base. 3 plus 2 plus 1. That sum is 6. 24 x to the 6th power. And you're done. (29) We have 5x cubed times 4x squared times 2x cubed. Okay? Switch the order in which you multiply. Yes, between the 5 and the x cubed is multiplication. Between the 4 and x squared and the 2 and x cubed, we have a string of multiplication. Let's emphasize it. Here, 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 and here. As you know by now, switch the order. 5 times 4 times 2. Put your coefficients next to each other so you can multiply. Put the exponentials next to each other so you can simplify. 5 times 4 times 2. Well, 5 times 4 is 20, times 2 is 40. I'm going to take my base x, I'm going to add the powers, because same base. Add 3 with 2 with 3. Take that sum here, same base. Keep the base, add the powers. You end up with 40x to the, looks like 8th power. You've simplified. 31. 2x squared, 4y squared, 3x to the 5th times y. Again, you have a string of multiplication. Switch the order. Because the order in which you multiply doesn't matter. 2 times 4 times 3. Now you got x squared times y squared times x to the 5th times y. We could continue to switch this order. You're going to have 2 times 4 times 3. Put the bases with x together and followed by the bases with y together. Don't forget power 1 here. So now I can multiply my coefficients, and I can actually use my property there for multiplying two exponentials with the same base. Keep the base, add the powers. 2 times 4 times 3 is 24, it looks like. X to the 2 plus 5. Y to the 2 plus 1. Let's see why. Same base, keep the base. Add your powers. Same base, keep the base. Add your powers. Final answer. 24, x to the 7th, y to the 3rd. And you're done. (33). We have an exponential here raised to a power. Now we talked about this in class. And so if you have a base with a power, and together it's an exponential, b to the nth power. Yet this exponential is raised to another power. That's the mth power. We've seen in lecture how, or we should say we've seen in lecture what this is actually equivalent to. We keep our base b, and we end up multiplying the powers here. So this is a property that we're going to be using here for doing the next group of problems. And let's go back again. Base b to the nth power raised to another power, mth power. Keep your base and multiply the two powers together. So in this case here, let's see. X squared raised to the 3rd power. We keep the base. But the power 2 and the power 3 now get multiplied together. This is now 2 times 3. Multiply your powers. You end up with x to the 6th power. We're going to use that property when we have a base raised to a power raised to another power. So 35, we have x to the 3rd power raised to the 3rd power. Keep the base, multiply the powers. Base x, it stays the same. 3 times 3, right here, gives you x to the 9th power. And you're done. (37) is x to the 4th power raised to the 2nd power. Keep the base, multiply your powers. Base x, base x, 4 times 2, we're going to get x to the 8th power. And you're done. (39) x squared, y squared, raised to the 3rd power. Now, we also seen in class what happens here. And I want to emphasize again something interesting. That you have two exponentials. They're two different exponentials that you can't combine, meaning they have different bases. So we wrote down a fact in class here, another property of exponentials. If you have b to the n, that's one exponential, times another exponential, let's say c to the m power. And notice again, multiplication with two exponentials that you cannot simplify. And they're both raised to another power. Call it p for power. We've seen that this is what happens. We keep the base b and we keep the base c still. Yes, we're still multiplying and we have those two bases. But now I'm going to distribute, meaning p will be multiplied to the power n, and p gets multiplied to the power m. Let's go back here. Let's illustrate. P gets multiplied to n. That's where we get np. P also gets multiplied to m, which is why we have mp here. So in some ways, we simply just say to distribute the power, meaning multiply both n and m, both powers, by p. And you keep the bases. And that's what we're doing here for this set of problems. So keep this in your notes. This is what we're going to be using here. And in this case, we now get x to the 2 times 3 times y to the 2 times 3. Notice again, I keep my base x. I keep the base y. And all I'm doing now is I multiply my 3 with 2 here and 3 with 2 here for each base. X to the 6, y to the 6. And you're done. So essentially distribute the multiplication with that power p outside to both variables or both exponentials powers. All right, 41. X cubed times y to the 4th raised to the 2nd. X, y. Two different bases. Here's x, and here's y. You're going to multiply 3 with 2 and 4 with 2. Distribute 2 times 3, 2 times 4. Distribute that multiplication of 2 to both of these powers. X to the 6 times y to the 8th. And again, you can actually write it this way without the multiplication symbol between the two. And that's what's most likely what you're going to see in back of the book. Because by default, this multiplication we don't have to put down. (43) 2x to the 4th raised to the 2nd power. Don't forget power 1 here. This is 2 to the 1 times 2, x to the 4 times 2, because we distribute the multiplication to both powers here. 2 squared times x to the 8th. 2 squared is 4. 4 times x to the 8th, better known as 4x to the 8th. And you're done. (45) 3x to the 4th squared. Remember that 3 doesn't have a power. By default, it's 1. 3, 1 times 2, x, 4 times 2. 3 squared, x to the 8th, 9x to the 8th. And you're done. We multiplied 2 with 1 and 2 with 4, here and here. (47) 3x squared, everything is cubed. Don't forget, power 1 by default. 3, 1 times 3, x, 2 times 3. Distribute that power 3 to both powers. Multiply. 1 times 3 is actually 3. 2 times 3 is 6. 3 cubed, we know, is 27. This is 27 times x to the 6, or simply 27x to the 6th power. (49) 4x cubed, y, everything to the 3rd power. Power 1, power 1. 4, 1 times 3, x, 3 times 3, y, 1 times 3. Distribute here, multiply. And here's what sometimes you see. Multiply every power here with that 3. 4 cubed, x to the 9th, y to the 3rd. Now 4 cubed is actually going to be, well, 4 times 4 is 16 times another 4. I get 64, x to the 9th, y to the 3rd power. And you're done. (51) 5x, y squared, squared. 5 has a power 1, x has a power 1. Don't forget to take the power 2 and multiply it to each power. So you'll get 5, 1 times 2, x, 1 times 2, y, 2 times 2. 5 squared, x squared, y to the 4th. 5 squared is 25. 25x squared, y to the 4th. And you're done. (53) 2x, y squared, z to the 4th, everything raised to the 4th. Again, don't forget, a string of multiplication here. Emphasize that. The power here is 1 and 1. So we're going to multiply every power by 4. I get 2 to the 4th, x to the 4th, y to the 8th, and z to the 16th. 2 to the 4th is 16 because it's 2 times 2 times 2. Let's write this down. 2 times 2 times 2 times 2. So that'll give me 16. 16, x to the 4th, y to the 8th, z to the 16th power. And we're done with this homework.